Professor Bob Young here, and we're going to talk in this instructional video on composition of functions and domain, or some textbooks will refer them as composite functions. So composition of functions, it says if f and g, some two functions, if are functions, then the composite function or composition of f and g is defined in this manner. Now again, remember I said there's good and bad ways to write things. This is the bad way right here. I'm going to put bad. And this is pronounced f of g of x. Or some students will say, and here's another bad way to write it, Young, you're putting me in the fog. So it is, that's another way of students to look at it. Don't put me in the fog. And here is the good way to write that composite function, f of g of x. So we're going to put good here. And really what you're doing is you're taking a function and you're putting it inside another function when you do these composite functions. So notice down below it says the domain of fog is the set of all real numbers x in the domain of the g function such that g of x is in the domain of f. And I know that may not make a bit of sense to you, but as we move along, I think it will. And I'll make sure it does, or at least try to. All right, so let's define a few functions here. F of x equals 2x minus 1, and g of x equals a fractional function here, 4 over x minus 1. So it says find the fog of 2, f of g of 2. Okay, so we'll just write that the good way here. Now notice if you write it the good way, you're kind of leaning toward doing something right away. If you write it the good way, you know, way back when y'all started taking math and algebra and you started talking about order of operations, you had Aunt Sally there in order of operations, our dear relative, and she always said do what's in parentheses first. So if you write composite functions the good way, we're going to go ahead and find what g of 2 is first. So again, remember, if we're going to find g of 2, we're simply going to take and plug in a 2 wherever we see an x here. So g of 2 would be 4 over 2 minus 1, which would be 1, or we would get 4. All right? Now, where are we going to take this 4 and stick it, Young? Well, let's go back up top here, and we are going to take and find f of g of 2, which is now 4. What do y'all think? All right, now Young, where am I going to take that 4 and put it? Well, let's go to a different color here. You know how I like to do colors, and I'll try to make them stand out. We're going to take that 4 and plug it in here wherever we see an x. So down here on the bottom, here we go. F of 4 would be 2 times 4 minus 1, and that would get us the value of 7. So are you in the fog yet? And not only can you have f of g, you could have g of f and be talking about goth. Or you could have h of g if you have two functions called g and h, and you could have hog. You could even put the same function in itself and have thoth. But anyhow, let's go ahead here, and here is one where we're going to take and find g of f of 3, goth, here. So we're going to say g, write it the good way, of f of negative 3. Now, what do I do first? And there's, as you do these composite functions, is where you want to go. You want to take the negative 3 and put it in the f function. All right, so that's what we're going to do first. And if you do that, f of negative 3 here, and I want to show the steps, is going to be 2 times negative 3 minus 1, and I believe that will get us a negative 7. So f of negative 3 will be negative 7. So always do what's inside those parentheses first. Now I think y'all will see we're to take that negative 7 and stick it. We're going to take that and put it up here in the g function. So again, it's like taking a function and putting it inside another function. So if we put the negative 7 in here, we're going to have 4 over negative 7 minus 1 will be 4 over negative 8. And always remember to reduce your fraction to lowest terms. Now notice it also says don't confuse composition here in this box with multiplication. Now remember, this is totally different creatures if we said f times g of negative 3. It is not the composite. This would be totally different. It would be f of negative 3 times g of negative 3. So, boy, I see a lot of students do that. Be careful. All right, let's find the fog here. We're given two functions, two fractional functions, because I know y'all love fractions out there. F of x equals 6 over x minus 3, and g of x equals 1 over x. So we're going to go ahead and find the composition functions f of g of x. So again, let's go ahead and write this the good way here, f of g of x. And with polynomials, we're going to take whatever g of x is, now this one doesn't have numbers in it, and just plug it in here. So that would give us f of 1 over x. Now where are we going to take that 1 over x and stick it, Young? Yes, we're going to stick it right there in for x. So as you can see, we end up with 6 over 1 over x minus 3. Now, some of you may remember this from previous courses as a complex fraction. You got fractions over fractions down here, and this is forbidden. So make a note of this. To simplify complex fractions, you want to multiply both numerator and denominator by the least common denominator of both. All right? Now, what is the LCD of this 6 in the numerator? Well, it's 1. I could actually make that a fraction if I wanted to, 6 over 1. The LCD of the bottom is x, so the LCD of both top and bottom would be x. And that's what we're going to multiply through by. So 6 times x will be 6x over x times 1 over x. The x's would chop out, leaving us with 1 minus 3x in the bottom. So I wanted to show you where this came from in the bottom. And it also does say multiply the numerator and denominator by x, but they really should have said by the LCD of both top and bottom, which is a fancy way to write numerator and denominator. All right, now looking at these two functions, we want to go ahead and find the domain of f of g of x. So we're going to look down here and say the domain, would y'all agree, of g is all real numbers except 0. So if I put 0 in here for x, that's going to be an undefined fraction. Okay? The domain of f of x is all real numbers except 3. So whatever makes the denominator 0 is going to make the fraction undefined. Division by 0 in math is undefined. All right? So it says the expression for g of x, therefore, cannot equal 3. See, so if I take that 1 over x and I'm taking this function and plugging it in the other function, it's going to impact it. All right? So what we want to do is we want to find the value that makes g of x equals 3 and exclude it from the domain of f of g of x. And there's my little puppy, Lucky, in the background again. Today is garbage day, so he's very unhappy at the window as he looks out. All right, so here's what we mean by that. So we're going to take g of x, which is 1 over x, and we're going to set it equal, so this g of x, to whatever that will cause f of x to be undefined, which would be 3. That will cause problems. So if we take this and plug it in here, we have to avoid some numbers here. So solving for x, we can go ahead and cross-multiply or multiply both sides through by x, and we can show that here. And we will get 3x equals 1 because the x's over here will chop out, so x will be 1/3. Now what does that mean? Well, it means that, remember, g of x could not be 0 to start out. F of x could not be 3. So when we plug g of x into f of x and it comes out 1/3, that will cause division by 0. So there's really two numbers. The one that made g of x undefined, 0. And when we plug g of x into f of x, we found that 1/3 would make it undefined. So we would say, now here's how you write this in interval notation. Check this out on the bottom. How do you write every number all real numbers in interval notation except 0 and 1/3. Wow. Okay, we got negative infinity to 0. Notice the parentheses does not include. Union, 0 to 1/3. All those numbers will work. Parentheses does not include. Union, 1/3 to infinity. That's how you write it. Pretty impressive, huh? All right, now given that we still got the same functions here, now we're going to find g of f of x, or gof, on this one. All right, so notice they're getting smart here. They went ahead and they wrote it the good way. So we might even put a happy face on this one. And then they were even better. They went ahead and plugged in what f of x was in there next. So Aunt Sally would say, do what's in parentheses first. So if we take that 6 over x minus 3 and plug it in here, so we're taking this whole function, and here's what I mean by this. I've been saying it. And we're putting it in here for x. And that's what we're getting down here. Now again, how do you solve this here? Now 1 divided by 6 over x minus 3, if you multiplied by the LCD of top and bottom, that would be x minus 3. That's one way to look at it. And the x minus 3's in the bottom would chop and we get this. And then we would have x minus 3 over 6. Now, note if x equals 3 here, we're going to have problems too. X can't be 3 there. All right. Now, given this, it says find the domain of what we just did. Now, the domain of f is all real numbers except 3. Okay, up top. And the domain of g is all real numbers except 0. So the expression for f, which is 6 over x minus 3, is never 0, since the numerator is the non-zero number 6. See, so no matter what they're saying here, no matter what number I plug in for x here, now of course I can't plug in 3, then it will never be 0 because I have a 6 up here. So that's looking good. So therefore, the domain of gof, or g of f of x, is all the set of all real numbers except 3, and that's a lot easier to write in interval notation. It's negative infinity to 3 union 3 to infinity. So again, with those parentheses on the 3, does not include. All right, now one more way to jerk y'all's chains here, so to say, is they'll define some functions and then they'll just have you evaluate them, you know, find gof and fog. And just in this case, we're going to show that g of f of x does not equal f of g of x in general. So first, we're going to find g of f of x. So we're looking down here. So we've got it the bad way. Here's the good way. And I'll go ahead and circle this in blue since it's in blue down toward the bottom there. So f of x is 4x plus 1. So wherever we see that, we're going to go ahead and just plug that in first. So f of x is 4x plus 1. Now, where are we going to take that 4x plus 1 and stick it, Young? Yes, up here. Wherever you see an x, you must plug that in. So if g of x is 2x squared plus 5x, here's what we're going to have. We're going to have 2 times f of x squared plus 5 times f of x. And then, again, be careful here. We're going to FOIL this. This is going to be 4x plus 1 squared. You have to take and multiply it twice, and that will be FOILing 16x squared plus 8x plus 1. Distribute the 5 through. So we're getting there. Finding g of f of x here. And distributing the 2 and collecting like terms here gives us this final answer for g of f of x. 32x squared plus 36x plus 7. Now we will find fog and show they are not equal, or f of g of x, the composite function. So some more good practice here. So we're writing it the good way. We know we're going to take and plug in the g of x here, okay, first. Now where do we take that 2x squared plus 5x and stick it? Back up top here. So wherever we see an x, we're just going to take it. I can write that right up here. Some of you may want to do that. And here's what we mean. So if f of x equals 4x plus 1, f of g of x, or f of 2x squared plus 5x equals, well, 4 times 2x squared plus 5x plus 1. And yeah, that's where we get it below there. And distributing and all that good stuff gives us this bottom line of 8x squared plus 20x plus 1 down here. So you can see that g of f of x is not equal to f of g of x. And finally, they may even give you some problems like this where it says find functions f and g such that f of g of x is x squared minus 5 cubed minus 4 times x squared minus 5 plus 3. Now note here that we have a repeated quantity of x squared minus 5. So it might be good if we let g of x be x squared minus 5, and we can define some function f of x where if we plug the g in there, it would come out with what's up top. So notice if we let f of x just be x cubed minus 4x plus 3, and if we took this and we plugged it in wherever we see an x, that would certainly give us what we're after. So there's other ways, and there's a lot of other ways you could do this too. You could probably do it infinitely many ways if you were a great mathematician, but that's just a real easy way to do it. So composite functions, functions inside of functions. Professor Bob Young signing off.